Okay, so once you know how to use the Pythagorean theorem, sort of extending it, taking the next step, there's a thing called the Pythagorean Converse, which we call it the Pythagorean Converse. Technically, it's the converse of the Pythagorean theorem. So you want to write this down. A converse means you change the order. The Pythagorean theorem says if you have three sides of a right triangle and they're A, B, and C, then A squared plus B squared equals C squared. So that's the Pythagorean theorem. You already know that. It starts out assuming you have a right triangle and says A squared plus B squared is C squared. Converse goes the other way. It says if you know you have just a triangle and you do the two smaller sides, square them and add them, and you get the square of the bigger side, then you have a right triangle. Okay? In other words, we're going backwards. Instead of saying, I have a right triangle, what can you tell me about the sides? It's, look at what's true about my sides. What kind of triangle is it? Okay? So if you have a side, if you have a triangle with side lengths of, for instance, square root of 3, 5, and what was this? Was it 8.58 or something? No. 5.3. 5.3. So if you have a triangle with side lengths of square root of 3, 5, and 5.3, but you didn't already know it was a right triangle, you could say it's a right triangle by the Pythagorean converse because it fits into the Pythagorean theorem and makes a true statement when you use those numbers. However, the Pythagorean converse is a little bit more interesting than that. It also tells me if it's not equal. Ooh, excuse me, I just put in equals. If it's not equal, and we're going to do this. If it's less, if A squared plus B squared is less than C squared, that tells me I have an obtuse triangle. And if A squared plus B squared is greater than C squared, that tells me I have an acute triangle. Now, to me, writing it this way kind of makes it hard to remember because this is a less than and it goes with obtuse and greater than goes with acute, and that sort of seems backward to me. So here's how I strongly suggest you look at this. Figure out what A squared plus B squared is. Like if you have three sides that are supposed to be a triangle, find your A squared plus B squared. Those would be the two smaller sides, squared and added. And then find your C squared and base your decision on C squared. In other words, if C squared is bigger, it's an obtuse triangle. Because that's what this says here. This says C squared is bigger than the other two squared and added. So if C squared is bigger than A squared plus B squared, it's obtuse. If C squared is smaller than A squared plus B squared, then it's an acute triangle. So base your decision on how C squared specifically compares to the other two squared and added. Okay? Your homework, page 2, looks like this. It actually says, first it says, determine if a triangle can be formed with the given lengths. If so, classify the triangle by angles. By angles means acute, obtuse, or right. Let's ignore the can a triangle be formed for a second and just look at the Pythagorean converse. In other words, the Pythagorean converse is how I figure out right, obtuse, or acute, which is what they're asking me to figure out. So let's ignore the yes or no for a second and just figure out if this would be acute, obtuse, or right. What are the two smaller sides? 7 and 12. Notice they're not in order. So I'm going to do 7 squared plus 12 squared. This is my A squared plus B squared. So A squared plus B squared is 49 plus 144. What's that? I believe it's 193. Is that right?
Yeah.
That's A squared plus B squared. And now I'm going to do C squared. C squared is 20 squared. So that's 400. So the question then is this number, is the c squared bigger, smaller, or the same as a squared plus b squared? Bigger means obtuse.
Would you circle yes?
Well, I'm skipping that question for right now. Okay? Yeah, I was skipping the whole yes or no. We're just looking at, is it right, acute, or obtuse? So let's do this one. All right, the two smaller sides are what? 15 and 8. So that's my a squared and b squared. 15 and 8. 8 squared plus 15 squared. So go ahead and figure that out.
289.
Okay, I'm hearing 289. All right, now the other side, c squared, I'm going to do 17 squared. What's 17 squared? It's also 289? So then the question is c squared bigger, smaller, or the same? Same, so what kind of triangle? Right. Okay, let's talk about the yes or no now. The yes or no is just triangle inequality. We kind of touched on it a couple chapters ago. Triangle inequality says to be able to make a triangle, the sides have to be able to meet. So any two sides have to add up to be bigger than the third side. These two do not. 7 plus 12 doesn't equal bigger than 90. I mean, bigger than, it's 19, so it's not bigger than 20. So this is actually no. So I really wouldn't even need the whole obtuse thing there. The only times it's a possible no is if it's obtuse. So in other words, check and make sure that the two smaller sides add up to be more than the bigger side. Is 15 plus 8 bigger than 17? Yes. Okay, this is separate from the Pythagorean theorem. We're not squaring on this. We're just this is just, is it any kind of triangle? So is 8 plus 10 bigger than 12? Yes. 8 plus 19 bigger than 20? Yes. 16 plus 30 bigger than 34?
Yes.
71 plus 5 bigger than 80?
No.
No. So you really don't have to do right, acute, or obtuse on this one, number 6. But the rest of these use the Pythagorean converse, the a squared plus b squared, and compare it to c squared to figure out right, obtuse, or converse. And make sure, right, acute, or obtuse, excuse me.
So if you circle no, you don't have to do that.
Right.